Hello, everybody. As Matt said, my name is Greg Neagle. I work for Walt Disney Animation Studios. I've been doing presentations for a really long time. I've been to a lot of different conferences, and sometimes I forget that maybe people don't know much about me, so I'm not going to make assumptions here. I'm the primary developer behind Monkey. I'm one of the developers that's worked on the Auto Package project over the years. I've released a bunch of other open source software. I've worked for Walt Disney Animation Studios since 2001. I've worked for Disney since 1996. Do we have anybody here that was born after 1996? I was afraid of that, yeah. Anyway, the title of today's talk is Being Responsible. Being responsible. And yesterday, Matt talked about, he said, what's up with the bees? Or at least made us ask him, what's up with the bees? And he mentioned an old Apple Tech note, which I remembered that, and I went searching on the Wayback Machine, because it's no longer available on Apple's website. And here it is. It's the infamous, as if it were a swarm of bees, you should stay away from the sync services folder. And I actually looked in my home directory, and I still have a sync services folder. And I'm afraid to delete it. So, I don't know. Anyway, today's talk is a story of a problem I ran into, some things I tried to solve it, more problems I ran into, some things I learned along the way, and ultimately a solution to this problem. And so what is the problem we're trying to overcome? What I plan to talk about today is a problem that has to do with TCC. And TCC stands for Transparency, Consent, and Control, and is the name of Apple's set of privacy protections. And these first showed up in Mac OS 10.9 Mavericks, and Apple has gradually added more and more protections in each subsequent release of Mac OS. You may also see the acronym PPPC, which I trip over because there's too many P's in there, and it stands for Privacy Preferences Policy Control, and technically PPPC really refers to the type of MDM profile you might use to manage TCC. So we get lots of acronyms just piling up on each other here. But these terms tend to get thrown in a blender, and you may hear PPPC or TCC sort of interchangeably. And at first, TCC protected only a few areas inside user home folders. But over time, it's grown, and they've expanded more. And now in macOS Ventura, at least, there's over 20 categories of TCC protections in the privacy and security settings pane. And in macOS Ventura, Apple introduced a new TCC protection that can affect Monkey and other management tools. I took this picture. This is on Canby Street, just down, just like a few blocks from here. I thought it looks like maybe it's some like funky, Rat Pack era sort of, nightclub sort of thing inside. But it's a beautiful neon sign on the front. I love that. Anyway, the new privacy protection that Apple introduced is called App Management TCC. And this limits what applications or what processes can modify, update, or delete application bundles. Items in the App Management list are allowed to make those changes. Items not in that list might be prevented from making those changes. And you might understand then why that might have the potential of interfering with Monkey, whose entire purpose is to install, update, and possibly delete software. Now, so far in practice, we found that this new feature doesn't generally interfere with Monkey, but in some cases it does. There may be some subset of packages or pieces of software that you need to install that will run afoul of this TCC protection, and Monkey won't be able to install them. So when it causes a Monkey failure, it usually looks something like this. You'll see something about installer complaining about an error, moving files to the destination, and whenever you're looking at a problem, if you ever see this operation not permitted, 99% of the time, that's going to point towards a TCC problem. So that's where you can start doing some investigation and go, okay, I think this might be TCC. Now I can start looking and see if I can narrow that down. So since admins rely on Monkey being able to install, update, and remove software, this new protection obviously could be a problem. how might we address this? We're going to need to figure out a way to give Monkey the needed TCC rights. We can, in theory, create an MDM PPPC profile and install it and have it pre-approve Monkey to make those changes. But what rights are you going to give it? You could give it app management rights. That makes sense. But you might elect to go all the way and give Monkey full disk access rights. And the advantages of doing that are you could install this profile on machines that aren't yet on Ventura. I mean, by now, maybe most of your machines are, but if there aren't any, the full disk access, you could install that on a Big Sur or a Monterey machine, and it will continue to work when it goes into Ventura. The converse is not true. Apple's MDM is dumb, and if you install a profile before the OS knows about it, when the OS is upgraded, it doesn't pay any attention to that profile at all. So if you were to install that app management profile too soon, it's not going to work. You'd have to reinstall it. So you might elect for going to full disk access. That also allows Monkey to do other things where they might hit into other protections, like if they're needing to access a network volume, or maybe you have a script that Monkey runs that's going to access some of the other privacy protected locations. So that would be my recommendation, is go all the way to full disk access. But still, what part of Monkey should we give these rights to? You might think, oh, well, I'll just take Managed Software Center and I'll add that to the profile, but that's not going to work because Managed Software Center is a user interface, but it doesn't do the actual installs. The actual software installs and removals and updates are done by the Managed Software Update command line tool. So, okay, let's give the Managed Software Update command line tool the TCC rights. But these tools, all of the Monkey's command line tools, are written in Python. They are Python scripts. And you can't give TCC permissions to scripts. You have to give them to a binary or an application. So maybe we give the TCC rights to MonkeyPython? But if we do that, anything that uses MonkeyPython now gets those rights. So that's probably giving the permissions too broadly. You know, since Monkey is used in a lot of organizations, if I'm a malware author, I might then go, if I penetrate this company's defenses and I'm inside, maybe I should start looking to see if they use Monkey, and if they use Monkey, hey, maybe I can use that MonkeyPython to get around TCC protections and start doing nefarious things. So that's probably too broad. You could do it, I wouldn't recommend it. You want to give the permissions to as narrow a thing as you possibly can. So how could we possibly give the TCC protections to Managed Software Update only, even though Managed Software Update is a script? So last summer, when I was testing the Ventura beta, I thought solving this problem would be pretty straightforward, because I'd already solved a very, very similar problem I had with AutoPackage. And like Monkey's command line tools, AutoPackage is also written in Python. It's a Python script. And I have a launchd job that runs every day, and it runs a list of recipes and it imports new stuff into my Monkey repo. And that worked great for years and years until I upgraded my macOS machine that was running AutoPackage, until I upgraded it to Catalina. Catalina added new privacy protections against network volumes. My Monkey repo, at least the local copy of the Monkey repo, is up on an NFS share. And so when the machine was upgraded to Catalina, those protections kicked in, and now AutoPackage was prevented from reading files on the NFS share, and it broke the AutoPackage runs. So that sounds really similar to the problem we're talking about with Managed Software Update. It's a Python script. It needs some TCC permissions granted to it. It's Python. I don't want to give it to Python. I want to figure out a way to give those rights just to the AutoPackage script by itself. And I came up with an idea. What if I wrote a really small compiled tool that called AutoPackage? And then what if I signed that tool and then gave that tool the TCC permissions? My thinking was, if that tool had the permissions, when it called AutoPackage, that AutoPackage would inherit those permissions and everything would work. So here's the source code for the tool. I call it Fudo, and I'll let you guess what the letters stand for. F-U-do. and this is the entire source code. It's a very, very small program. You use it kind of like you use sudo. It just calls the next thing. And so my thought was I would give foo these TCC permissions, and that would allow AutoPackage to access the network volumes, and then things would start working again. So I built foo, and I signed it, and I installed it on my AutoPackage box, and I gave it TCC permissions, and then I edited my launchd job. Originally, my launch daemon just called my AutoPackage script directly, and what I did is I edited it to insert foo in front of that. So foo would then run the AutoPackage script. And it worked. My daily AutoPackage run started working again. So, being very overconfident, when I became aware of this TCC problem in Ventura with Monkey, I thought, oh, well, this is going to be pretty simple to work around. I can do the exact same thing with Monkey. So I built a foo-like wrapper for Managed Software Update, and then I asked people on the Monkey dev list, hey, can you test this out? Does this solve the problem? And a lot of people pitched in and tested it and reported back, and many people reported success with the exact test that I asked them to do. But there were other testing scenarios that people came up with where it failed. And when it did fail, if you looked at the unified logging, you found out that it was Monkey's Python that was being identified as the responsible process, not the wrapper that I had written. And I just couldn't understand why this was happening, because I expected the compiled wrapper to be the responsible process, just like it was with my AutoPackage solution. And part of the problem in figuring this stuff out is there are several different ways that you can call Managed Software Update. It's fairly complex, because of course you can run it manually from the terminal. You can just type, sudo Managed Software Update, or you can SSH in a machine and do that. But if it works, it's not necessarily because Managed Software Update got the TCC rights. Very, very common, you may look at on your machines right now, you've already given terminal those rights, or you've already given SSHD those rights. And so when you call Managed Software Update via the terminal, via SSHD, it inherits the TCC rights from the terminal, and so it just works, and you think, well, there isn't a problem. But Managed Software Update is also called from a launchd job. And that's how all the background jobs work. The fact that it runs once an hour in the background and stuff, that's launchd job. Or when Managed Software Center, the GUI app, triggers a run, it's really just triggering a launchd job to do that. And when it's run via launchd, the permissions that terminal or SSHD have, they don't matter, because terminal and SSHD are not involved at all. It's launchd directly running Managed Software Update. So it's very important that somehow we get those TCC rights into Managed Software Update. So here's one of the launchd jobs that could result in attempted updates or installs of applications. And you can see that it, like all of the, not all, but many of the launchd jobs, it doesn't actually call Managed Software Update directly. Instead, it calls a different tool called Supervisor. And Supervisor, in turn, later runs Managed Software Update. And Supervisor itself is a Python script. And it was written to kind of add some more features there. And the two key ones are killing a stuck monkey job. If the monkey sits around too long, it'll kill it. And also randomizing when monkey runs, so that not your entire fleet isn't hitting your monkey server at the exact same time for those background runs. It randomizes it over a period of time. So this environment's a little bit more complex than we originally thought. We've got Managed Software Update, which is being called by Supervisor, but those are actually Python scripts. So really, it's MonkeyPython calling Supervisor, which calls MonkeyPython, which calls Managed Software Update. And we need to insert our compiled wrapper right before Managed Software Update runs. But we can simplify this diagram a little bit. Supervisor and Managed Software Update are not actually processes, they're scripts. So we can combine the MonkeyPython and the script into a single thing. So this is a little bit simpler to understand what we're doing here. So I'd given TCC permissions to the wrapper, and I expected that the OS would allow it to modify app bundles, since I thought it would be the responsible process. But instead, the OS seemed to decide that MonkeyPython was a responsible process, and since MonkeyPython did not have the TCC permissions, the install failed. But why? Why was MonkeyPython being considered the responsible process and not my wrapper? Why was it skipping over that? I didn't understand that. So quite often when we work with these complex, frustrating, mysterious things called computers, especially called Macintosh, we have a mental model of how things work. It'd be great if we had the documentation. Often we don't. So in our brains, we've kind of come up with our mental model of how something works. And I had in my head a certain model of how TCC works to decide whether or not to allow a restricted operation to proceed. And here's how I thought it worked. Let's go back to my success with AutoPackage. A process, say in this case, AutoPackage being run by Python, attempts a TCC restricted operation, in this case reading a network volume. And the TCC mechanism checks to see if the current processor has rights to do it. And in this case, it doesn't. So then I assumed that TCC then checked the parent process and then sees if that parent process has the appropriate rights, and so on, up the process list, until either it encounters a process that does have the correct rights, or it runs out of parent processes, in which case it goes, nope, you can't do it. That's how I thought it worked. And given that model, I then expected TCC to work like this with the managed software update and the wrapper. Managed software update would attempt to modify an application. TCC would see that MonkeyPython did not have the correct rights. It would then check the parent process, which is the compiled wrapper. That wrapper does have the needed rights. So I expected TCC to allow the operation to complete. But that's not what happened. Instead, TCC seemed to be ignoring the wrapper altogether and just checking to see if MonkeyPython had the needed rights and failing. And I looked through Apple's documentation, and I kept looking at different logs and figuring out how to do predicates with log show, something I have to learn from scratch every single time I need to use it. I cannot remember that stuff. Grepping a text file was so much simpler. But anyway, Apple's logging, no help. Apple's documentation, no help. And very frustrating, trying to figure out why MonkeyPython is identified as the responsible process. So obviously, my mental model of how TCC works was wrong. It didn't fit the observation. So we've got to come up, if we're going to be scientific here, we've got to come up with a new hypothesis. We've got to come up with a new model. So let's think about this. Let's go the other direction. Let's go back to what we were doing with AutoPackage so we can check this, and let's see if we can come up with a new model here. Maybe instead of starting at the bottom and working our way up to the top, maybe it starts at the top. So when AutoPackage attempts to access a network volume, let's propose that TCC starts at the top of the process list. And we're going to say that launchd is special case, that since launchd ultimately launches everything, it never is considered the responsible process. It would be crazy if it was, because it ultimately is responsible for launching every single thing on macOS. So we'll say that that gets ignored, and that the next thing is what gets checked. So we descend the list, and we see that TCC decides that Fudu must be the responsible process. Fudu has the needed rights, and so AutoPackage is allowed to make the install. Now, if we apply this model to the managed software update run, let's see how that works. Launchd can't be responsible. We descend to MonkeyPython as it runs the supervisor script, and TCC decides that MonkeyPython is the responsible process. Since MonkeyPython doesn't have TCC rights, the operation is not permitted. The wrapper is never even considered. It doesn't go that far. It decides right then and there, we're done. That seems to better explain what we're seeing in the real world. This model seems maybe closer to the right thing. So it also suggests a possible strategy of how we can deal with this. What if the wrapper called the supervisor process instead? This would put the wrapper at the top of the calling chain, just below launchd, and presumably the wrapper would then be identified as the responsible process, and our TCC restricted operation would be allowed. So, what if we wrap supervisor instead of managed software update? Let's think about that. I immediately came up with some problems with that idea. Because as currently written, supervisor can call any binary or script. And so if supervisor gets special rights, malware could abuse those rights. They go, oh, I see that this organization runs monkey, let's go use supervisor, which has the TCC rights to do bad things. Also, if you were to call managed software update directly, like via terminal or SSH, any way that doesn't use supervisor, it might not work because it would not have the correct rights. We've only given it to supervisor, but we haven't given them to managed software update. So I think technically that would have worked, especially for the background runs of managed software update and the anything that was done by LaunchD. But I just didn't like the solution because it felt like there were security issues with it, and that it was going to cause a lot of support issues when people tried to run it manually, and it behaved differently than when it was run automatically. So it didn't look good. And things were looking pretty bleak at that point, because I just didn't really see a clean way to solve it. I did have some thoughts about, well, what if I modify supervisor so it could only call managed software update? It's not a generic tool that could call anything. Or maybe I could rewrite supervisor in C or Objective-C or Swift maybe. Definitely not Go. But I could do those things and maybe have it be the wrapper. But I just really couldn't find an approach that, one, I was happy with, and two, that I was actually capable of pulling off with my limited skill set. I'm not a great C programmer. My ability to code in Objective-C and in Swift is largely due to Apple's autocomplete in Xcode. If I just had to do that, on a blank text editor, I would be in big, big trouble. So I wanted to at least find something that I understood that I could handle. But it wasn't looking good. But a new character. January of this year, Corey Prince contacted me on MacAdmin Slack. And he was asking questions about Monkey and TCC and these problems that we were seeing in Ventura. And we traded information back and forth for a few days, and it quickly became clear that he had done a lot of research, and he knew way more about how TCC worked than I did. He pointed me to this web page, and this web page had some information about TCC I had never encountered before. It was very interesting. And this new information, at least to me, suggested yet another model for how TCC determines the responsible process. So in this new model, the responsible process is assigned when the process is launched, and then each sub-process inherits that responsible process from the parent. So let's see if this model matches our observations. LaunchD launches Fudu, and the responsible process is recorded as Fudu. Fudu runs a bash script, and the responsible process for the child process is also recorded as Fudu. The bash script runs autopackage via Python, and again, it inherits Fudu as the responsible process. So let's try it with managed software update. LaunchD launches MonkeyPython to run the supervisor script, and the responsible process is set to MonkeyPython. Supervisor launches the wrapper, which launches managed software update, and in each case, the processes inherit the original MonkeyPython process as the responsible process. Since MonkeyPython does not have the TCC rights that we need, any restricted operations are going to fail, and this matches what we've seen. Okay, so we have two models now that seem to match our observations. And this third model, it doesn't really seem that different from the second model. So why should we pay closer attention to it? Well, this is something that Corey found and pointed out to me. It turns out that there is a way for a process to say, I'm not responsible for my children. We could call it the deadbeat dad approach. The process, when it launches something, it says, I'm not responsible for it. It's going to be responsible for itself. And it stops the inheritance of TCC, or of the responsible process. So now that child process becomes responsible for itself. And that's exactly what we want. We want the wrapper to be the responsible process instead of just inheriting the first monkey process, the MonkeyPython process launched by LaunchD. And we want something that looks a bit like this, where the wrapper gets assigned as the responsible process. But a process can only declare that they're not responsible for their child processes. they can't declare that they're responsible for themselves. So that thing that declares that it's not responsible for its children has to happen before the wrapper is called. If we do it in the wrapper, it's too late. If the wrapper declares it's not responsible for its children, the child process again becomes monkey Python, which again does not have TCC rights, and it just doesn't work. So how do we solve this? Do we need two wrappers? A first wrapper to declare it's not responsible for its children, and then a second wrapper to call managed software update? This is getting really complex. Well, Corey Prince, again, hero of our story, came up with the idea of having the wrapper call itself. So it calls itself sort of in a loop, and it declares itself not responsible for its children. This second wrapper process then picks up the responsibility, and it can call MonkeyPython to run managed software update, which then inherits the TCC permissions of the wrapper, since the wrapper is now the responsible process. And not only did Corey come up with this idea, more importantly, he wrote the initial implementation. He wrote the code. Much easier for me to look at the code, understand it, and tweak it than to start completely from scratch, because his original implementation was in, I think, straight C, or maybe it was Objective-C. I think it was C. And this approach also works when you're running managed software update directly via a terminal session or over an SSH connection, because the wrapper then still becomes the responsible process. So we're getting closer to a solution to our original problem. Now all we need to do is rename a few things up here. Let's rename our wrapper tool Managed Software Update, and let's have it call MonkeyPython to run a managed software update.py script. So now we can just run managed software update like we always have, and the existing launchd jobs can also do that, and nobody even has to know that that wrapper exists. And this, finally, proved to be a successful approach. And this wrapper, now renamed Managed Software Update, could now be granted either app management or full disk access rights or any other TCC rights you wanted to give it. Monkey 6.3 shipped with this wrapper implementation at user local Monkey Software Update, but Monkey admins still had to do something. They were still on their own to sign it with a developer ID so they could create a PPPC profile. I personally did not want to sign it with my developer ID. I didn't want people at Facebook that were upset that their machines were being managed to call me up and go, "What's this Greg Neagle software doing on my machine?" I didn't want that. I was pretty sure, I didn't even ask, but I was pretty sure that Disney Animation also did not want the same responsibility. So I figured, you know, if this affected you, your organization was going to have to sign these tools themselves. And to me, that didn't seem like a huge showstopper, but it's still non-trivial, especially if you've never done it before. So the people in the Mac admins open source team came up with a nice alternative. Nate Walk and Eric Gomez, as part of the Mac admins open source team, are making signed and notarized builds of the Monkey tools available here. And these signed and notarized builds are done via GitHub Actions, and they make use of Monkey build scripts that Eric improved so that it signed a larger portion of the code so that it could then be notarized. And the Managed Software Update tool is now signed with the Mac admin's open source developer ID. And this allows you to build an MDM PPPC profile that should continue to work for future builds of Monkey that are made available at this same site. So we finally have a happy conclusion to our tale, and we learned a few things. We learned that how we might grant a script TCC permissions. We discovered that how TCC works is probably more complex than it first appears, at least more complex than I thought it was. And we found a way to control what process is identified as the responsible process. You might be able to use some of these lessons to solve similar problems in your own environment.